Hi everyone, welcome to another class in our IFI 101 Option School. Today I will be talking about theta and how to use it to correctly roll covered calls. This class builds on the time value of options class that I did just a few days ago. So first I will quickly review what we learned in that class, namely the definition of time value and how the time value decays. Then I will define theta and show you an example that I used just today to figure out whether to roll an NVIDIA call or not. And finally, I combine all this into a short option rolling guideline. So let's quickly jump to the definitions. As we know, option price consists of two parts: the intrinsic value that does not depend on time, and the extrinsic or the time value. Right? The intrinsic value for call options, when the call option is in the money, it's just the difference between the stock price and the strike price. And if the option is out of the money, meaning the strike price is above the stock price, then the intrinsic value is zero. And the intrinsic value does not change with time. On the other hand, the extrinsic or time value changes with time. It decreases as the option nears expiration. And finally, at expiration, the time value of any option is zero. And the time value is the difference between the option price itself and the option's intrinsic value. So here are a couple of charts. These are three-dimensional charts. The chart on the left comes from the Black-Scholes model, and it's for some hypothetical stock with a value at 50. And we can see the typical parabolic decline of the time value for at the money options, right? So if the underlying price does not change with time, the time value, or the value in this case, because the time value and the option value are the same, it decreases parabolically. On the other hand, for the out of the money option, you can see the decline is first kind of linear and then finally it levels up. And we can see the same behavior for the real stocks and real options. This is for SPY calls a couple of weeks ago. So let's look at it a little more detail. So I looked at different expirations and different strike prices for SPY calls. It was a Friday a couple of weeks ago, and SPY on that day closed at 407.26, and these are the different time values for different expirations and different strikes. And you can see, so this is the at the money strike price, and so this point right here, this is 1 week till expiration, right? So 1 week till expiration, the option has a long way to go, lots of time value to lose. Whereas between, say, this is week 6, I think, between weeks 6 and 5, it loses only a little bit of the time value, right? So most of the decline is in the last week. On the other hand, for the out of the money option, most of the decline is in between weeks 2 and 3. So, and the last week, definitely the decline is small because the value of the option is already small. There is not much value to lose. Here is a different look at the same data, just sliced differently. The top line is for the strike price of 407. That's the at the money option, and on the x-axis are the different expiration. And you can see the further till expiration, the higher the time value, and the time value decreases. And again, for the at the money option, this is some kind of parabolic decline, right? It looks like this. On the other hand, for the out of the money option, the last week, the decline is really slow. And the previous weeks, it's relatively straight, but you can see the biggest decline is here in week 3. We want to leverage this information when we are rolling our calls from 1 week to another. So if I want to formalize it, I would use the option Greek called theta. And theta is just the rate of time value decline. So Theta is provided by most trading platforms. So essentially here is a screenshot of SPY a couple weeks ago. And you can see that for the March 3rd expiration, strike price at 407, Theta was 21 cents. For the out of the money options, Theta was smaller, like 14 cents. And for the in the money, roughly the same, 21, 22 cents. This is what I was looking at this morning, or actually it was around 1 p.m. Eastern time, so 3 hours before closing. So I was looking at NVIDIA. NVIDIA was trading around 237.77, and I have a short call at strike price of 250. And currently it's trading between 88, 89 cents. And I was trying to figure out whether to roll it to 1 week later, to March 17 expiration. So this one is expiring in just 3 days, March 10th. This one would expire 7 days later. So in total 10 days, March 17th, sorry. So I looked at the theta for the option that expires in 3 days, and that's 42 cents. And I looked at theta for the option that expires in 10 days, and it's 34 cents. So the time decay of the option expiring in 3 days is faster than the time decay of the option expiring in 10 days. So just based on this information, it's clear to me that I'm better off holding this option and waiting a few more days before rolling to the next week. So as I said, theta of the option expiring in 3 days was bigger than theta of the option expiring in 10 days, so I decided not to roll the option. On the other hand, if I had an option expire, with a strike price of 260, let's look at this. 260 is right here. You can see theta is 11 cents for the 3-day option. On the other hand, the 10-day option, theta is 22 cents, so twice as much. So if I had 260 strike price, if I was short the 260 NVIDIA call, then I would definitely roll it from the March 10 expiration to March 17 to capture a little more of the time value decay. So that's how you can use theta to kind of guide your decisions on when to roll and to what expirations or even to what strike prices. So what are the guidelines then? So first you should decide which strikes you want. For me, it was easy. I just wanted to keep the same strike price. I didn't want to go any higher or any lower. And I was just considering whether to roll it 1 week out. That's all. And so I looked at theta for each of the strikes and expiration, and clearly it was beneficial in order to maximize theta, right? It was better for me to stay at the option that I have. Now, one caveat to that is that, so if there is a outsized move in underlying, all this analysis can change. Unfortunately, today there was an outsized move in NVIDIA. So let's take a look at it. So at the time I took the original screenshot, NVIDIA was about 237. And at the close, the NVIDIA was around 232, right? So that's a move of about $5, which is a 2%. So 1-day move in a stock of 2% is pretty large. NVIDIA is pretty volatile stock, so it's not so uncommon for NVIDIA, but still it's a large move. So let's see how it affected the stock prices and other things. So when I look at the 250 call, right, originally traded somewhere around 88 cents, and now it's trading somewhere around, say, 36 cents. So that's a difference of 50 cents. So the value of the call got smaller by 50 cents, which, because I'm short the call, essentially it's $50 per contract in my pocket. Oh, great, awesome. However, if I rolled the option at the time I made the original screenshot, if I rolled the option, it was trading around, say, 330 or so, 333, and then uh, after after a few hours, now it's trading at 215. So that's a difference of almost $1.20, right? So this call expiring in 10 days, let me just write it here. This is 10 days, and this would be 3 days. So the call expiring in 10 days had a much larger move, right? From 330 to about 210, say. So it's about $1.20. So I would be better off doing the roll this afternoon rather than waiting and holding the option. But of course, I could not predict what NVIDIA is going to do, and I definitely did not expect for NVIDIA to move 5 points lower. So why such a difference in the change in option price between the two calls, March 10th and March 17th? Well, the reason is delta. So that's another Greek that I will talk about in a different video, but you can see that the delta on the original screenshot, the delta for the 3-day option was 15 cents, whereas the delta for the 10-day option was 29, say almost 30 cents. So it was double. So delta essentially tells us, so precisely, if the stock price moves up by $1, the option price will move up by 15 cents. And if the stock price move down by $1, the option price will move down. In this case, call option will move down 15 cents. And similarly here, if the stock price moves up or down by $1, the option price will also move up or down by 30 cents. So this is where delta comes from, and this is why it's important to also look at delta when you're making your decision. If NVIDIA went up, that would be a move against us. So the roll would not be beneficial, right? So I cannot control the stock movement, but I can control theta. I can see what theta is and make my decision based on that. So I'm still happy with the decision that I didn't roll the call at the time I was looking at it. And tomorrow I will look at it again. And if we have theta here, if we have theta for the 3-day call smaller than the theta for the 10-day call, then I will definitely do the roll tomorrow. Anyway, that's all for today. I hope you found my presentation valuable. If you did, please click the like button below the video and also subscribe to our channel, because there are many more presentations like these coming up, and hopefully at least some of the presentation will make impact on your trading and improve your profits. Thank you, and until next time, happy trading.